is Ricardo Gonzalez. Here are my teammates Alejandro Diaz, Osvaldo Fernandez, and Christian Ramos. We'll be presenting our senior design project, which is the development of the 2015 Formula FSAE chassis suspension. Our advisor for this project is Dr. Andres Ramate. So here's the agenda for today. The picture you see here is a prototype of our prototype design for the chassis and suspension. So a little background. What is the Society of Automotive Engineers? Well, FSAE is an international professional organization that concerns itself with setting the standards in various industries, especially those concerning with automobile and aerospace vehicles. Formula FSAE is a design competition hosted by FSAE International, where each of its collegiate chapters assume the role of an imaginary company. This company is tasked with building a Formula-style, open-wheeled race car for the average weekend race car driver. These cars are generally built towards a strict set of competition rules and are evaluated based on efficiency, performance, design, and cost. Generally, teams design their chassis out of a tubular steel space frame, which you can see right here, a carbon fiber monocoque, or a hybrid of the two. And their suspension design is generally a double wishbone suspension with either push or pull rod actuation for the springs.
So, for our project, we decided to split the entire prototype into 6 systems: suspension, chassis, powertrain, drivetrain, aerodynamics, and ergonomics. For our senior design project, we'll be concentrating on the design, manufacturing, and testing of just the chassis suspension. But all 6 systems need to be integrated into our design. So, for our design process, first we start by analyzing the tire data. This will tell us where the tire needs to be. After that, our suspension geometry will be designed. And after suspension geometry is designed, our suspension hard pickup points on the chassis will be placed in space with all our major components of the vehicle, figuring out centers of gravity and so forth. After that, we improve performance based on our goals, and then we test and tune our prototype.
Here we have some of our preliminary goals. We would like to reduce the weight of both the suspension and the chassis. We would like to increase the torsion and rigidity of the chassis itself, improve the design for future vehicle efforts as well as manufacturing, and to reduce the cost of the vehicle. We also like to reduce the overall vehicle envelope, basically make the car as small as possible. Here we have some of our proposed suspension parameters. We were choosing a wheelbase of 60 inches, which is the minimum allowable, minimum allowable wheelbase as per the rules. And using the following pages, we were able to come up with our front track width as well as our rear track width. Here we have a representation of the data matrix we compiled in order to determine the results of our vehicle, basically. We kept all things such as the drivetrain, powertrain, center of gravity, height, weight of the vehicle, etc., all the same, and we just changed these parameters as compared to the current vehicle's parameters. And you can see above, we see that the car is about a second faster around the track. Here we have our cost analysis. We divided the cost analysis into chassis suspension. We tried to include as much of the manufacturing as possible in our cost, although we do plan on manufacturing 90% of the vehicle in-house. The only thing we will not, I'm sorry, let me correct that percentage. The only thing we will not be doing in-house is notching the pipes. They'll be laser notched in order to give us the appropriate thickness desired for welding purposes. Here we have our timeline. We're currently in the research and development phase, as well as conceptual design. Here we have our responsibilities for each team member.
All right, so what we're essentially developing is a race car for the motorsports industry, which helps the automotive industry because in these competitions, the rules and regulations that are imposed on teams push the teams of engineers to find innovative solutions to automotive problems. And because we are competing in an international organization, we have access to FSAE journals and papers. And we have the opportunity to network with various companies and teams from around the world. Any questions?
Close the presentation.
Are you going to put an engine in this to test it?
Yeah, absolutely. So the idea behind this was, since we decided to do Senior 1 in the spring and Senior 2 in the fall, just for our curriculum and landed that way, we are in the process of developing our 2014 chassis, which we have a month left to competition and will be complete. So due to budgeting and I happen to be the president, and we are all members of that organization right now, we decided to use the same powertrain and have a powertrain development team on the side next year, which is not part of our senior, but still part of our organization, to continue the efforts on developing the one-cylinder 450cc engine that we're currently using. So a lot of our components next year will be rolled over into our 2015 chassis and chassis and suspension, and we'll just be developing a brand new chassis and suspension for them. So we basically, in December, we present them with the kind of like a base of the car, so they could just continue working till May of next year.
Okay, you basically communicated that your new design was 1 second faster?
Yeah.
Roughly 1 second. This is just a simple design matrix that we compiled.
Okay.
It could be less or more depending on further simulation and crunching of numbers, depending on where our center of gravity.
Okay, I challenge you to make that number a number that's more significant. Okay, 1 second in error or in measurement error alone will be fine. And at the end of the day, putting all of this effort in and not getting anything achieved from it, other than obviously your degrees from it, isn't really where you should be. So, you know, I'd go back on design this time and see if there's any opportunity to make that better.
In order to expand upon what Ozzy says, the 1 second faster came from just changing the length and the width of the vehicle. It wasn't really improving upon the actual suspension geometry. It was just by reconsidering the wheelbase to length ratio of the car.
Okay.
So that's where our preliminary design came from.
So is that really engineering design? I mean, that's a pretty simplistic.
Well, we're still in the design phase. We haven't
Okay.
completely designed, set up our suspension geometry, things like that, that nature. But we're working in that direction. This was just a preliminary test to make sure we were moving in the right direction. We didn't want to be going the complete opposite direction with our design.
Right. I mean, I love the idea, but I think it's a big enough task that your target, at least at this point, should be much higher than that. So that even if for some reason some of it doesn't happen, you still achieve something.
I guess just to add to that, are you pursuing any optimization exercise or effort?
Oh, yes.
We are planning to incorporate more chassis simulation. Like we have various programs like Optimum Lab and Lab Simulation software, which will allow us to better understand how any change that we do from the 2014 to the 15 chassis and suspension will improve our performance goals. And we're obviously trying to maximize our goals as much as possible.
I noticed you had 4130 as a steel tubing.
Chromometer, yes.
Have you thought about using like 7075 aluminum?
We wanted to stray away from aluminum simply due to two reasons. The difficulty in welding, since we're going to weld it in-house as well. I weld most of the stuff for the team.
I'm just learning to weld.
I mean, I'm not, let's say, not too sure of myself welding round tubing and aluminum. I have welded aluminum plates. I've welded several aluminum parts.
You can practice.
But just for sake of manufacturing, we wanted to keep it steel oriented, and as well as aluminum. In the rules, you were required to develop a new list of specs for the vehicle. You don't follow the same thickness and diameter rules as with steel, and that will throw us into a whole deep end in further research and development necessary just to produce the vehicle.
Because it's a weight issue, the 7075 has almost the same tensile strength as 4130. So it's almost as strong. They may be just as strong. I'm not quite sure of the numbers, but it's pretty close.
And
it
also
would weigh a lot less.
And also to expand on that, by competition rules, they treat generally all aluminums the same. So regardless, you would still have to make it a lot thicker. All the tubes would still have to be a lot thicker than if you made it out of 4130.
No, you need to change your engineering thought then. Because 6061 or some of the other ones is not anywhere near as strong as 7075.
So you're saying you have a minimum weight you got to meet?
A minimum tube thickness?
Right, right.
aluminum?
Tube thickness, yes.
For the chassis, it's if I'm not mistaken, 0.065 inches of tube thickness for the general chassis, and then for the roll hoop portions, in case you were to roll over, they want these parts to be stronger. It's 0.095 inches. Those are the thickness, and it all outside diameter 1 inch for steel.
Now, going back to the 1 second thing, what was 1 second in what in a lap in a quarter mile?
It was an FSAE lap.
A whole lap?
A track that they used in the previous year. We ran the simulations on that track.
And what was the total time on that?
Total time, if we go back to the slide,
That was too fast. I missed it.
it was around 1,500 seconds.
1,500 seconds. Yeah, you're right, Chip. If it was like a 50-second and you took a second off, yeah, that would be significant.
Well, I mean, in the motorsport industry, you're doing multiple laps. So if you consider making 1 second increase every single lap, by the time you're done with the race, you're 50 seconds, you do 50-second laps. I mean, you do 50 laps.
Well, that's
Yeah,
not really a
the concern I really have is that your calculation may be off by
Right,
10%.
yeah,
right,
You
and it's
add that up,
0.9.
It's all gone. It's all
Right.
gone.
No, we definitely agree. There's further testing simulation necessary in order to make these goals a reality.
We definitely just, we wanted to, I mean, we're a very premature team. This current vehicle we're working on is, I would consider our first vehicle. So we just wanted to make sure we're going in the correct direction with our second vehicle.
Because if it was a 30-second, I think a second, I think we should have enough, right? And it's really 0.7 seconds.
More questions?
Okay.